Welcome back to Flipped Friday. Today's topic, solving multi-step equations. Your purpose today, I can solve equations requiring the use of multi-steps. There are three simple things to remember. D, C, I. They stand for distribute, combine, and inverse. Just like the order of operations, we're going to have these be our order of solving. You're first going to distribute any numbers that need to be distributed, combine any like terms, and then use inverse operations to solve. Let's look at our first problem. 2 times the quantity x plus 8 equals negative quantity x plus 5. Remember, that negative sign in front really represents a negative 1, so I'm going to rewrite it with the negative 1 in front. We're going to first distribute. 2 times x is 2x. 2 times 8 is 16. Negative 1 times x is negative x, and negative 1 times 5 is negative 5. Watch out for those signs. Now we're going to use inverse operations to solve. I'm choosing to get rid of the negative x on the right-hand side by adding x to both sides. I'm doing this because negative 1 is smaller than 2. When I compare the coefficients, I always want to move the smaller coefficient. That removes the x's on the right-hand side of the equation, and I'm left with 3x plus 16 equals negative 5. Continuing with our inverse operations, I'm going to subtract 16 from both sides of the equation. That removes it from the left-hand side, leaving us with 3x equals negative 21. We're going to continue with inverse operations. Divide by 3. That removes the 3 from the left-hand side of the equation, giving us x equals negative 7. These problems are complicated, so I want you to make sure to check your work. We're going to start with the original equation, substitute in negative 7 for x, and follow the order of operations to solve. We're first going to combine the parentheses. Negative 7 plus 8 equals 1, and negative 7 plus 5 equals negative 2. On the left-hand side of the equation, 2 times 1 is 2, and negative 1 times negative 2 is negative 2. So the problem checks out. Let's look at another problem. This problem has parentheses, so we first need to distribute the 3 to the b and the 3 to the negative 4. That gives us 3b minus 12 plus 3 equals negative 2 plus 5b minus 9. Notice the rest of the equation was written exactly how it was in line 1. Now I'm going to combine like terms. The constants negative 12 plus 3 add to negative 9, and the constants on the right, the orange, negative 2 minus 9, give us negative 11, still on the right. I need to move things around in this equation, so I have my variables all on one side and my constants on the other. I'm going to do this using inverse operations. I'm going to add 11 to both sides of the equation. This removes the 11 from the right-hand side. Negative 9 plus 11 gives us 2 on the left-hand side. Now I'm going to move my variable. Using, again, inverse operations, I'm going to subtract 3b from both sides of the equation. Again, I'm choosing to move the 3b because 3 is smaller than 5. This always helps to keep the coefficient positive. So the 3b's are gone on the left side of the equation, and I'm left with 2 equals 2b. Following with our inverse operations and dividing both sides by 2, the 2 gets removed on the right, giving us the answer b equals 1. We're going to check this work by substituting in again to the original equation, that 1. Following the order of operations, doing the parentheses first, 1 minus 4 is negative 3. And now moving from left to right with multiplication, I have negative 9 plus 3 equals negative 6. Negative 6 equals negative 6, so I know my solution is correct. Let's try another equation. This one has fractions. Don't panic, we've done fractions before. First, we need to distribute the 1/2 to the 3m and 1/2 times negative 4. This gives us 3/4 m plus 2 equals 3/2 m minus 2. Now I'm going to use inverse operations and add 2 to both sides of the equation. This gets rid of the 2 on the right-hand side of the equation, So I'm left with 3/4 m plus 4 equals 3/2 m. That 3/2 m doesn't have the same denominator as the coefficient on the left. So I'm going to change it to 6/4 so that both coefficients in the equation have the same denominator. Now I can use the inverse operation and subtract negative 3/4 m from both sides of the equation. This gets rid of the 3/4 m on the left, leaving us with 4 equals 3/4 m. Now the coefficient is a fraction, so I'm going to multiply both sides by the reciprocal 4/3. This gets rid of the coefficient on the right, leaving us with m equals 16/3. That's an improper fraction, so when I change it to a mixed number, it becomes 5 1/3. Now let's check our work. I don't want to put in 5 1/3 as a mixed number, so I'm going to input 16/3, the improper fraction. This looks kind of crazy, but notice I've put parentheses around each place where I replaced 16/3 for m. Now I'm going to multiply. 3 times 16 is 48. For the numerator, 4 times 3 is 12. My plus sign drops down, my 2 drops down, my equal sign drops down, and my 1/2 in the parenthesis drops down. 3 times 16 is 48, and 1 times 3 is 3. Minus, notice in the purple I've changed the negative 4 into 12/3. I did that so I'll have a common denominator when I subtract them later. In the next line, I've dropped the 48 twelfths down, changed the 2 into 24 twelfths so I can add those fractions, and I've combined my like terms in my parentheses. 48 minus 12 is 36/3. Combining the fractions on the left, I get 72 twelfths equals 36/6. 6 does equal 6, and so my answer checks out. I'd like you to try these problems for class tomorrow. They look complicated, but use your notes you just took. Don't worry about making mistakes. We're going to do them together in class, and I'd rather have you try them and make some mistakes and find some errors than to not try them at all because you're afraid to. Go ahead and try, and we'll see you tomorrow.